Welcome to Talk Universe. I'm your host, Sir Charles Schultz. This is our show for Wednesday, December 14th, 2016. Tonight we have an open lines question and answer show that I think you'll find fascinating. Lots of things people have questions about they've found in their lives they can't quite explain and have questions about and have a very hard time getting the answers for them. Now, with all of the really esoteric shows we do, black holes and robotics and alien life and mathematics and quantum mechanics, it's only fair that people often have more down-to-earth questions, and so this show is devoted to getting right to the heart of those questions that many people have that have more prosaic and down-to-earth applications. So we'll see what we can do about that tonight. We also have a great list of upcoming shows. Our next show will be about navigation. We're going to look at its history and applications. We'll discover how GPS works, inertial navigation, gyroscopes, the history of navigation, how we discovered how to get around and how to know where we are in the universe, or even on the surface of the Earth. We'll have our co-host, Ed Minchow, available for that show. He's always got some fascinating research and insights. He's going to be a lot of fun to talk with. We'll also be doing Mars Part 3 very shortly. We have an interview scheduled with Barry DiGregorio, the astrobiologist. He's been working for a number of years with Dr. Gil Levin, who was responsible for the design and operation of the biological detection packages that were on the Viking 1 and Viking 2 spacecraft back in 1976. There's been some very controversial, let's say that the results of his findings were not well accepted by the scientific community, and for over the past 40 years, there's been a lot of controversy about it still. In my opinion, he found what appears to be very clear evidence of biological activity on the surface of Mars back then. If anybody deserves a Nobel Prize, this man does, and so we will see what's been going on that on our Mars Part 3 interview with Barry DiGregorio, some of the research they're doing to try and answer that question, is there life on Mars? We're also looking at an interview with Dr. Lynn Rothschild from NASA. She is a person responsible for gene tailoring microbes that specifically target rare materials in electronic and microcircuitry trash. And it's going to be a fascinating show. She's a NASA scientist who has done some amazing things that can help us clean up our environment. And again, I'm going to try to get Charles Ostman back on the show for another fascinating interview. I think we really enjoyed the two-part show with the interview he did about technology and AI and whether we're wrecking our environment, our planet. Well, we've got so many subjects to talk to him about that I think everybody will really enjoy. And also, I've been invited to do an on-site look at the third geothermal borehole project that's going on the island of Montserrat in the Caribbean, the West Indies. They have a pilot geothermal project on the island to generate all their electrical power. 2 boreholes have been completed. The third one is now in progress. And we're going to look at the generation of power from geothermal energy here in the Caribbean. A lot of people aren't aware that there's quite a bit of volcanic activity here. They have also the Montserrat Volcanic Observatory, one of the world's foremost volcanic observatories. I'm going to see if we can get an interview with some of the scientists there and possibly talk to some people in the government here about the development of geothermal power and self-sufficiency. So we do have a great lineup coming, and tonight we're going to go to the listeners' questions and see if we can answer some of them for them. Also, keep in mind, you can always go to Facebook and see the talkuniverse.org page there and post your questions and comments, and we'll look at the best ones and put them on the air. If you have any questions, we will answer them for you. You can email us at admin@talkuniverse.org as well. So keep the questions coming in. We're going to be answering a lot of them tonight. So let's get started with some of the questions. The first one here is from PEL32AM, and it's a good one. I've just gotten out of the shower, and now I'm cold. I thought I had hot water on me. Yes, actually the answer for that's very simple. It's called evaporative cooling. You are covered with droplets of hot water. But what happens is this. Hot materials have molecules that move faster, and cold materials have molecules that move slower. And the fast-moving molecules of water, the hottest ones, are the ones that evaporate first. And guess what's left behind on their skin? All the cold water is left behind. So evaporative cooling is a very effective means of getting something to cool off. In the past, without refrigeration, people took advantage of it. Recently, a fellow was granted an award for developing a refrigerator that consists of 2 clay pots, one inside the other, with sand between them, and he pours water in the sand layer between the 2 pots and the water evaporates through the clay pot to the outside. This is an unglazed ceramic pot, and it chills the inside by enough to keep your food fresh for a few days, up to 3 days. So in areas of the world, such as third world countries where there's little or no electrical power, this is the device that allows them to keep their food longer. So fascinating concept, evaporative cooling. So here's an interesting one from Cool Rod Anubis. I'm going to assume he's a welder from his name and his question. Why does metal get hard when it's flexed? Well, this is called work hardening or metal hardening. This is because metal is not a molecule, so to speak. It's atoms, yes, but they're together in crystals, in layers. Think of layer cakes and how if you have enough frosting, one layer will slide over the other. But what really happens is metals are rarely very pure, and so there are dislocations in the crystal. There are impurities in the metal. And these are areas where the layers will slide as you flex the metal, but when they hit one of these discontinuities, these breaks in the crystal order, they jam, they lock up. And so after 3 or 4 flexings, these flaws or jams prevent the metal from moving very much, and it'll break instead of flexing. Now, work hardening can be used to toughen up metal, like gun barrels. They're rolled to make them tougher. On the other hand, if you flex metal too much, it will fracture. If you work aluminum, anybody who folds and hammers aluminum, they'll notice that the aluminum will work easily, and then in a little while it'll start fracturing and tearing. Have you ever wondered why we don't make automobiles, the bodies of automobiles, out of aluminum? Because it would be very lightweight and it would save us a lot of gas. It would be far more efficient. The problem is that we don't do it because with steel, you can stamp a door or a body panel in one operation because the steel will draw properly without ripping. With aluminum, we would have to have it stamped partly, reheated to soften the metal a little, temper it, annealing. We would have to do that 3 times on average to get the same stamped part that we do with steel. So you'd have to have 3 molds, 3 heating and stamping cycles to get one finished part out of aluminum when you can do it with one shot with steel. That's why we don't use aluminum to make body parts for cars. And here's a hint. If you do work aluminum, keep a small bottle torch, a little propane bottle next to your workbench. Part of the way through the operation, reheat the metal with the bottle torch to soften it up a little. What this does is it sort of resets the clock. Annealing removes some of the flaws and smooths out the crystals so it can move again. And if you're working aluminum, this can save you a lot of grief. You won't destroy your part by fracturing it, by overworking it. So there's just a useful hint for anybody who likes to work aluminum and even copper. Oh, and by the way, if you've ever seen a roll of copper wire that says annealed copper, this is because when they make wire, the wire is pulled. It's rolled, it's pulled, and it's drawn through a die to stretch it out to its final shape. And this puts a lot of stress on the metal. It gets it ready to fracture. So copper wire particularly is put in an oven after the wire is drawn, and it's heated to anneal it, to remove the stresses in it so that it's flexible again. Otherwise, you wouldn't really be able to wire anything with it. The first time you bent it or did a couple of bends with it, it would break, and you certainly don't want that. Okay, here's a good one. We have one from Pueblo Stewart 53. When I turn the shampoo bottle over and a stream of liquid is falling inside the bottle, it sometimes loops and jumps like it's bouncing off the other shampoo in the bottle. What makes that happen? This is an interesting effect. I think everybody's seen this at some point. You turn the bottle over and a thick liquid like honey or like shampoo particularly, a lot of it will run to the bottom of the bottle, and then some of it will develop a string hanging down, and it's flowing, and it bounces off the other fluid. This is the result of something known as a non-Newtonian fluid. This is a fluid that doesn't work the way you expect. An example of a non-Newtonian fluid would be ketchup. When you stir ketchup, it actually gets thicker as you shear through the fluid. With shampoo, and sometimes even with water under the right circumstances, you can see this beading or bouncing effect. If you've ever gone to the sink and you've seen water dripping, particularly in some dishwater, You will sometimes see it splash, and sometimes you'll see a bead of water develop that floats over the top of the other water. How can a bead of water develop? Well, there's an interesting effect here. When water or any other fluid contacts itself, and it takes a certain amount of time for that bead or stream to rejoin the rest of the water due to its surface tension, and sometimes due to a static charge. If the charge is repulsive, like they're both negative, for instance, the bead will float for a while so that the charge is not allowing it to rejoin. In the case of the shampoo, if it's moving slowly, then the stream that's falling will have time to rejoin the liquid below. If it's moving fast, it's forced to. It's got a lot of force behind it. But at just the right speed, the fluid will bounce off more rapidly than it can join the other fluid. And so then you see these strange arcs and loops coming off the fluid. So that's a non-Newtonian fluid effect, something fascinating to see. Incidentally, if you have these water beads floating in your sink and you put a high voltage charge over the water, the beads will collapse. That's an interesting observation somebody made about 20 years ago. Now here's one from a Marshall Mallow from Springfield. Why is chlorophyll green instead of red or blue? That's also a very interesting question. We look at all the green plants around us and we wonder why. Why is it green? Many people just accept that, but that's a great question, and it has to do with the sun itself. Early in the Earth's history, in the distant past, the sun was much dimmer and cooler, and it's been discovered that the earliest photosynthesis was done by purple instead of green compounds. There's a compound that's in your eye called rhodopsin, or visual purple, and it's very sensitive to green light, which is the peak of the spectrum output of the sun. The sun outputs more green light right in the center of the spectrum than any other frequency. It would have been best for plants to be able to absorb as much of this light as possible back then, and rhodopsin is a very simple molecule. And there are purple plants today. But over time, chlorophyll developed because as the sun got brighter, you needed photosynthesis, but you also needed the ability to reject a lot of that energy so the plants wouldn't literally cook. Photosynthesis is a good balance. And strangely, photosynthesis works best with chlorophyll because chlorophyll absorbs red light very effectively. A lot of hydroponics uses red lighting almost exclusively. Now, on other worlds where the star has a different color or a different spectrum, a lot of scientists feel that other molecules, it might be orange or pink or anything, might be the dominant color of plant life there. We don't really know yet, but one interesting discovery is that some molecules are capable of doing photosynthesis using infrared light. Now, why is that interesting? That's because there are a lot of stars in the universe, particularly in our galaxy, that we can see with telescopes that are dim stars, brown dwarfs, and they give off little or no visible light, but plenty of heat. Well, if you were a plant in an environment like that, you would actually need an infrared photosynthesis compound. And the discovery of those things on the Earth leads us to believe that it's quite possible that there could be plant life even on dark worlds around dark stars like the brown dwarfs, which would be fascinating, a truly alien world, a dark, warm planet with plenty of dark plant life around you. What an interesting environment to think about. I've got one from a Wellington in Brighton. When I stir my cuppa, that's the British term for a cup of tea. When I stir my cuppa, the pitch of the teaspoon sound drops as I stir my sugar into the mix. What, pray tell, would be the cause of this effect? You have two things going on here, Wellington, and one of them is sound waves are affected by the density of the medium that they travel through. Helium is a very light gas, and if you speak with helium in your lungs, you get a squeaky voice. And sulfur hexafluoride is a very dense gas, and it drops the pitch incredibly. Your tea is getting more dense as the sugar dissolves in it, so the pitch of the sound is dropping. And it's also losing heat, which makes this tea more dense as well. So with the solution of the sugar and the loss of temperature, the pitch is dropping. By the way, we're going to have a lot more of these questions and answers after the break. I'm your host, Sir Charles Schultz. This is Talk Universe. Send us more questions. Send them online. Post them to the talkuniverse.org page on Facebook. We'll be listening. Looks like we got some pretty good questions coming in for the show here. Interesting ones, really interesting ones. Here's a good one. This is an anonymous one, and it says, I was at a beach recently, and as I was walking, the sand was squeaking. What makes some sand squeak? Squeaking sand is an interesting phenomenon. I was down on the Gulf Coast just about 3 weeks ago near Apalachicola. There's a national park, and I noticed squeaking sand there. This is an old phenomenon, one that a lot of people have seen. Normally, sand grains are convex. They stick out pretty much all over. Squeaking sand, when examined under a microscope, has an interesting property. The grains have hollows or cavities in the sides. And so when they rub together, the points of some grains slide inside these little sockets and vibrate. That appears to be the cause of squeaking sand. So we were walking on the beach down there, and it was squeaking away, and it's a really interesting effect. But you can feel that it crunches differently than other sand. It has a different texture to it, a feel to it when you walk on it. Don't know if there's any practical application for squeaking sand, but it surely is a fun and interesting thing. Here's an interesting one. Armin44, can we get free energy from radiant power? Well, radiant is a pretty generic term. Light is radiant. It is being radiated from, for instance, the sun or a flashlight or whatever. You can get power from a source that is radiating, obviously. Solar cells pick up radiant power from the sun and convert it to electricity. A lot of people probably would be thinking of the Tesla radiant wall, that sort of technology. What that really is the air is full of radio waves and electrostatic charges and all sorts of power. And so if we're clever, we can harvest that power. Some of it is done with something as simple as a diode. A diode is a device that allows electrical current to flow in one direction, but not the other. It's like a check valve for electricity. If you have a small antenna or a loop for picking up a signal, and you have a diode in there and a capacitor to store it like a tiny battery, then yes, radio waves or other disturbances can be rectified and stored up in a capacitor, but it doesn't generate much. You would have to have thousands and thousands of them in parallel, and each of them would act to sniff a little bit of power out of the environment around it and save it up. So you can do this. It's kind of an expensive proposition unless you can mass produce thousands of these things at once. And, we have the technology to do that. On the other hand, the density isn't very great. In my opinion, right now we have technology to actually gather a lot of power from other sources, whether it's radio waves, electrical fields, charges, even sound waves using piezoelectric microphone devices. We can gather quite a bit of power from the environment around us and do it quietly, subtly, the same way plants do with sunlight. Incidentally, I was speaking of photosynthesis earlier. Plants only absorb about 1 to 1.5% of the sun's energy and put it to use. The rest of it is wasted. So, we have a great advantage over photosynthesis just with standard solar cells right now. So yeah, you can do it. The expense for an individual to put a system like that together would be pretty high. You'd have to devote a lot of time and effort to it. But systems like that are manufactured, they certainly would gather some power for you. Ted in Des Moines says, on cold mornings when I go outside and I start my rig, I suppose he means a truck, yeah. Smoke rings are sometimes seen coming out of the exhaust pipe. And this is an interesting phenomenon, yes, it is. Ted, what's happening is basically inside the tube, the exhaust stack, there is a pressure wave coming out from the engine. The detonation of fuel sometimes inside the cylinder or even in the pipe itself, perhaps, if it's a rich mixture, will cause a shock wave to move up the tube. And the interior, the core of the air in the center of the tube, is moving fast. And the air that's dragging on the pipe at the outer edges is moving slow. And so this creates a vortex. And so once in a while, you'll see smoke rings pop out of the stack. I've seen this myself on cold mornings, and it's because Normally when such a vortex forms, there's very little in the way of particles or anything to make it visible. They're there, we just don't see them. But on a cold morning, the moisture can condense, and now you're seeing the moisture, the water vapor, make the ring visible. So smoke rings do come out occasionally from diesel stacks. I've seen the same effect when they launch a rocket out of a tube in the ground. Many of the old defense systems had tubes mounted in the ground to fire them, and when the rocket would fire, a smoke ring would come out and envelope it briefly before the rocket took off. It's a fascinating effect. That brings me to another interesting thought. If anybody has gone online to YouTube and looked at dolphins playing with air bubble rings, the dolphins have figured out how to blow a bubble out of their blowhole and move their snout rapidly through it to generate a vortex, and they literally make vortices of air, a ring-shaped air bubble spinning in the ocean, and they play with them. That's a really interesting thing to see. Go to YouTube and have a look. You'll see dolphins making vortex bubbles of air underwater and then playing with them. Leslie in Chicago writes, what's the deal with the saltwater batteries that I see demonstrated for cars in Europe? Well, electric cars can run off just about any kind of battery that there is, and saltwater batteries have been around for a while. They really aren't news, but the application of them for automotive work is. Now, people are under the mistaken impression that just by pouring seawater in a container, you can get electricity out of it, even if it's a special container like a battery. Well, yes, you can, but what you're doing, batteries work by corroding something. It's a controlled corrosion in many cases. When you're using salt water or seawater or anything salty to power a battery, you absolutely know that somewhere there's a piece of metal that's being consumed in the process. Usually it's aluminum or some other reactive metal. Now, yes, you're getting electricity out of salt water that way. What you're really doing is the salt water is the electrolyte. It's the thing that's eating the metal. You're getting the electricity out of the metal by destroying it. And what this comes down to is you're not getting anything for free because you still have to make the metal. It takes an awful lot of energy to manufacture aluminum. And aluminum is highly prized because when it's recycled, one of the things you can do with it is save 95% of the energy of making the aluminum by melting it down and stamping it into something else. So when you're using aluminum in these saltwater batteries, you're consuming a huge resource in terms of energy. It isn't cheap. It certainly works, but it isn't cheap. We're paying for it up front in petroleum or coal. So, nothing is free. Nothing is free, and we're using our energy to make the aluminum in the first place, and we're not getting but a fraction of that back in the battery to power your vehicle. You're way better off with something else. And that's another thing. Batteries are not a primary power source. They're not generators. They store power, and when you use a battery that generates power, creates power, you're really using power that was created somewhere else to make the materials to make the battery. And if it's a one-shot battery, a non-rechargeable like these seawater batteries, you have a lot of density. But again, it doesn't generate the power. Somewhere somebody burns some coal or some petroleum or some sort of power source to make the materials to make that battery in the first place, and that power is gone. Now here's one that's on a little bit of a different track. Manta in Palmdale says, why is some hair curly and some straight? Believe it or not, some people might say, well, genetics, this, and so on. I can tell you this. The chemistry of the hair is almost identical, but what is different is the shape of the hair, the cross-section of the hair. Straight hair, if you could take a hair shaft and cut the end off of the razor blade and look at it under a microscope, a straight hair is invariably going to be round, and a very curly hair is going to be flat or elliptical and oval. So the shape of the hair shaft is what makes the hair have its curliness or its straightness. It's actually a geometry thing, and what creates that is the size of the hair follicle, the shape of the hair follicle in your skin. So there is a genetic program that creates that, but the hair that grows out of it is shaped by the hair shaft, by the root of the hair,
and the hair that comes out of it is either round, which would make it long and straight because it's got an equal amount of force all around it, more or less, or it's going to have a flattened shape, and the flatter it is, the curlier it will be as a general rule. So the shape of the hair in cross-section is what controls whether it's straight or curly. And that's a pretty broad answer. There are other factors, but that's the major one right there. And by the way, an interesting fact about hair, a lot of people don't know this one. Some animals have hairs that are hollow, like a drinking straw. And in polar bears are white typically, and they have hollow hair shafts. And this acts actually to make them slightly insulating, better insulators than solid hairs. Now, sheep also have hollow hair shafts, hollow like straws, but there's an important difference. Sheep hairs are full of an oily material called lanolin, and so most of the lanolin that you'll find is actually made by boiling down and reducing the lanolin out of wool from sheep. That's an interesting and curious fact. Let's have a look at some of these. Let me look through some of these here. Okay, here's one that is very interesting. Marty in San Bernardino asks, how does color change paint in a coffee cup work? Okay, first of all, there's a name of that, and it's called Thermochromic in that case, because when you pour a hot drink into the mug or the cup, it changes color or a message is revealed, and that works in a very interesting way. The thermochromic or heat-sensitive color dyes are made in a number of ways, but they typically come down to a crystal that changes its shape or its structure when exposed to heat. And there are many different types of them. Commonly, they'll come in like reds, blues, black, white, but they come in all colors. And a lot of research was done in this in ceramics many, many years ago for displays, electronic displays, and they found many different ways to do it. But basically, when heat energy is applied, there are little loops or tags on the end of the molecules that vibrate and change their configuration, and this changes the way that it reflects the color or absorbs color. And so thermochromic paints and thermochromic ceramics are made with molecules that change their crystal structure and therefore the way they appear to light waves. And here's an interesting thought. A lot of people have light-sensitive sunglasses, the blocker sunglasses, the glasses that change dark when they're exposed to ultraviolet light, for instance. And the way that works is a little bit different. There are many, many, many tiny granules of silver inside the glass. And the silver, when hit by the ultraviolet energy and the sunlight, charges up, and it makes the clusters of silver atoms get together. And when they're spread apart, they're so tiny that they don't block the light waves. But when they come together in these tiny microscopic clusters, they get big enough to block some of the light waves. And so the photosensitive sunglasses are made with tiny granules of silver in the glass, and the granules of silver move around. When they cluster up, they block some of the light and get dark. When they spread out, when the charges dissipate, they get so small that they don't block the light at all. Back in the 1980s, there actually were companies that made voltage-controlled color displays in ceramic, and some of these things had the ability to act like capacitors. When you set the color by changing the voltage on it, it would remember it when the power was turned off. They had some interesting usage, and I saw one display that was made out of what looked like wall tiles, and they really acted as the color pixels in a display, and a computer could draw different colors on the tiles. So they looked just like a standard ceramic tile, but would change color when a different voltage was applied to it. And I think that has a lot of really interesting possibilities. Imagine murals being put on buildings where there are no moving parts and nothing else involved, but a computer sets the voltage on each tile and they become the pixels in a big display. And when you turn the power off, it would remember the last display that was on there for some period of time. I think that we have a lot of technology that was invented and then just kind of shelved under the radar, and we just don't know it's there. And now, today, with all the things we're doing, some of these things are going to show up in some pretty amazing places. Imagine buildings that can change color on demand, or the room, your shower, your bathroom, being able to dial it to a different color on demand. What an amazing world we live in. I'm Sir Charles Schultz. We'll be back after the break. even have a building where you can dial up any color on any wall and it'll stay that way. You can change the color of your vehicle, patterns, artwork, graphics. They already have shoes and garments that change with displays that glow or remain in different colors. Everything is coming alive. There's a dynamic to things that never existed before because the things we're learning, the things we're doing can turn everything into a chameleon. We've got alloys that change their properties, plastics that remove pollutants from the water, pieces of metal that can remember the shape they were with the application of a little heat, plastics that act like muscles, materials that can change from insulators to conductors. We even have materials that conduct heat in one direction better than the other, so from end to end they feel like metal, but from the sides they feel like wood. It's a pretty amazing place, and it's getting more amazing every day. Let's look at some more of these questions and see what sort of things people want to know about. Here's a great one. Gary is asking, what makes a germ become resistant to an antibiotic? That's an excellent question, Gary. You know, every organism has many, many genes inside, and a lot of the genes don't seem to be doing anything. They're thought of as junk DNA. But in fact, they turn out to be a library of routines that can be called upon when times are tough. And so, think about germs as having cartridges of backup routines in their software. And when they encounter tough situations, they're able to rewrite their code a little bit so they can deal with it. That's basically what we're up against. Many germs have dozens of other routines in them that allow them to break down or defeat poisons or to live in pretty toxic environments. And with mutations added to the effect, you can get a fountain of basically endless solutions to problems. We can learn a lot from something as simple as germ, you know. Here's another good one. Mary in Poughkeepsie says, how long can a satellite stay in orbit? That really depends on a couple of things. First of all, altitude. If a satellite is at a lower altitude, its orbit will decay faster because even though it's a vacuum, there are still some air molecules up there, and they will slowly steal some of its momentum. They'll slow it down, like braking it, putting on the brakes. At a higher altitude, there's much less atmospheric drag, many fewer atoms to run into, and so above about 500 miles, they can stay up for hundreds of years. If you go up a couple of thousand miles or more, you know, you're probably not going to bring it down. Now, the other factor is mass. Something very lightweight is going to slow down much more readily than something with a lot of mass behind it. So even though the space station, the International Space Station, is a couple of hundred miles up above the Earth in orbit, there is enough area to it, even though it weighs many tons, because of all the solar panels and all the surface it has, that the drag that it encounters from the thin atmosphere of the Earth up at that altitude is enough to slow it down. And so every time they launch a mission, when they dock with the space station, whether it was a shuttle, which they used to use in the past, or whether it's a Soyuz from Russia, those vehicles would attach to the space station, they dock to it, and they would fire their engines to push it into a slightly higher orbit to keep the orbit from decaying. And if we don't do that on a regular basis, the space station, the International Space Station, eventually will tumble back to the ground. Now you might say, well, why don't we move it higher, where it'll be easier, it'll last longer? Well, the problem is with the vehicles of the day, the space shuttle, going much higher than a couple hundred miles would have been a real issue because it didn't carry enough fuel to do that and make it back to Earth. We have real limits to the space travel hardware we've had since the 80s, and I'm looking forward to a day when we don't have to worry about that. And there's a lot of things we can do about it. But anyway, that gives you a decent answer. Now, a lot of times you may hear that satellites in geostationary orbit, which are 22,300 miles up, have a lifetime based on how much fuel they carry, and that's true. Typically between 5 and 10 years, and usually a lot less than that. And it's because of this. Even though they'll remain in orbit, they won't remain in the proper place in their orbit. Now, this is because the Earth is not perfectly uniform inside. It has concentrations of mass that are of greater density, called mass cons. And so when you put a satellite up at geostationary orbit, it needs to stay exactly where it is. It needs to perform station keeping to stay there, or the antennas won't be able to find it. So the fuel on board has to fire to correct its position every so often because of these irregular structures inside the Earth that pull it slightly off center or off its intended position. So that's what limits the lifespan of a satellite. And by the way, if you go to a site called spaceweather.com, you will find that the weather of our solar system, which is obviously controlled by our sun, has a great influence on the atmosphere, and during certain periods of solar activity, our atmosphere will expand slightly and increase the drag on satellites. So it's important to watch the space weather. So paradoxically, even though you're above the weather, you're up in space, there's a different set of weather conditions that apply to space, including proton flux from the sun, magnetic field changes, and radiation changes. So spaceweather.com is an interesting thing to look at. And by the way, if you like astronomy pictures, go to APOD, A-P-O-D, Astronomy Picture of the Day, apod.com, and every day they have an astronomy picture plus a huge archive of pictures about space and space-related hardware. So if you are into satellites, it's definitely worth a look. Okay, here's a question from Gary in Little Rock, and he says, I've seen lenses for visible light and I've seen lenses for infrared, but can you make a lens for X-rays? That is truly a very astute question because, yes, lenses exist for all sorts of materials. For X-rays, obviously, you can't just color some glass or shape some glass. Basically, we use a slightly different effect, and that is a lens for X-rays can be made in two different simple ways. One is to use graze angles. Use a surface that the X-rays strikes at a really acute angle, a very high angle, and it will reflect off that surface because the difference in density between air and that material, and it could be a metal, will cause it to reflect. If you take even a sheet of paper and you hold it at a very shallow angle and you look across it, you will see at just the right angle it begins to reflect pretty well, considering it's paper. Well, the same thing can be done using a graze angle method, and actually this is used in the Compton Space Telescope, which uses graze angle optics to focus gamma rays into it and do gamma ray observation. But the other way you can do this for X-rays is you can make a lens out of layers of lead and aluminum that have different thicknesses that are kind of lens-shaped overall. And so X-ray lenses can be made out of highly different materials in density like aluminum and lead, and the shape of the lens is lenticular, it bulges out, and so the thickness of the metals changes, thicker toward the center and thinner toward the edges. So just think of a cross-section of a lens made of two different metals, and you're on the right track. X-ray lenses can be made that way. Now consider the following. What if you make a lens-like substance that focuses the radiation to another place? Well, then you have a form of shield. If you look at a lens, when you focus, let's say, the light through a magnifying glass, all that energy ends up at a focal spot, but there's a dark area completely around it where the light doesn't go. Well, using the same strategy, you could use the X-ray lens to literally deflect radiation away from you and act as a shield. So some smart people who are good in shaping materials at a nanoscale could probably make some sort of radiation shield out of very lightweight material by texturing it properly, layers and textures. This seems to me to be a worthwhile pursuit, so some smart guys, let's get on it. Here's one right off social media. Martin asks, if energy can neither be created nor destroyed, why is there an energy crisis? It's all about availability. There's energy everywhere, but a lot of it is in forms that we can't capture or use. Imagine just random heat energy a couple of degrees centigrade above your room temperature. It would be difficult at best to get any of that in a form that you could do anything with. So the crisis in energy has nothing to do with the physics of energy. It's all about having energy in forms that we can easily get our hands on and put to use. After all, there's a big difference between a bottle of hydrogen and the bottle of water that ends up in your hands after you burn the hydrogen. You can't get any energy out of the water the way you could out of the hydrogen. Now, at this point, I'm going to break and stop answering questions and go right to our Singularity Watch. There's something really fascinating that the holiday season really needed. There is a group that took an AI similar to the Deep Dream Google AI, and basically in the University of Toronto, they took this AI and they fed it all sorts of things about Christmas. It was given 100 hours of Christmas music and 50 hours of song lyrics and video feeds from the game Just Dance. That's crazy. And what this program did is it wrote a Christmas carol, which they call neural karaoke. And basically, it's described as being pretty terrifying. So anyway, there are misuses for singularity technology and AI technology. I don't even want to think about what they're thinking of doing next, but keep that in your mind when you're thinking of the singularity and happy holidays. Christmas carols written by AIs. Here's another very fascinating piece of information. The research on macaque monkeys shows that the structures of their throat and mouth actually support the ability to speak, but their brains are not wired for it. It's not an anatomy issue, it's a brain wiring issue. And this was reported by researchers at Princeton University, and it's in the open access journal Science Advances. So fascinating stuff. There are actually animals that have the structural ability to speak, but don't have the neural wiring to support it. Another one is scientists have been able to do a restoration of communication in minimally conscious patients. They're using basically brain scanning methods to communicate with people who basically are in a comatose or incommunicable state. So being able to study the brain in a brain-injured person and measure the signals in it, they're able to construct actually responses to questions and statements. So we now know that even though many people are in a comatose or near comatose state and don't seem to be able to communicate, with the new technology we have, we're able to see what's going on in their heads and actually communicate with them and find out that some of them are quite conscious. Recent studies done a few months back show that roughly 1 in 6 are fully conscious but unable to tell you they've seen the same reruns, heard the same conversations, and been laying in that room basically locked in their own body like prisoners for very long periods of time. Pretty amazing. Well, okay, I have to admit, for a fascination for this Deep Dream style Christmas carol, let's give it a listen.
Christmas tree is filled with flowers. I swear it is Christmassy. I hope that is what you say. The best Christmas present in the world is a blessing.
Well, I think that's about as much of that as I can stand. Also, I'd like to hear your opinions on the news that President-elect Trump has selected Elon Musk as one of his advisors. Personally, I think it's a positive step. Anyone who would select Elon Musk among some of the other technophiles and developers we have today as an advisor is starting out in the right direction. Personally, that's just my opinion. I'd like to hear what you think about that. Now, I'm going to give you a closing thought or two here. One of the things I've noticed is there seems to be a drive among a lot of people in development these days of systems that can answer any question and tell you the answer to anything you want to know. But I think this is not as a good idea as people think it is. And the reason is very simple. Many times if you ask a question and you're given the answer, and it's just a quick answer, you don't necessarily gain an understanding of your subject. So it limits your search for information. But the other thing is, when you go on a search for something online and you start going through search engines, you find fascinating things along the way, and you end up coming away better informed on 5 or 6 different subjects than when you began. So maybe having the quick and dirty answer to your question really isn't a good thing. Learning to do a little search on your own, learning many other connected subjects, or even only mildly connected subjects would be a good thing. Enjoy your evening. I hope you liked the show. Come back to Talk Universe again. I'm Sir Charles Schultz. Good night.